Hello students, the topic of today's lesson is limiting and excess reactants. After completing this lesson, you will be able to define terms like limiting reactant and excess reactant, and identify limiting and excess reactants of a given chemical reaction, and finally, calculate or determine the amount of product formed in a chemical reaction based on the limiting reactant. The lesson note of today's topic is shown on the screen, and you can read, study, and refer this note by pausing the video. In most reactions, one of the reactant is usually present in excess amount. At the end of the reaction, some amount of this reactant will be left over or remain unreacted, and the other reactant will completely consumed in the reaction. This type of reactant is called limiting reactant. Simply, limiting reactant is the reactant that is totally consumed when the chemical reaction is completed. And the excess reactant is the reactant that is not used up completely when the limiting reactant runs out. Let us consider the following examples to understand the topic. The first example is 42 grams of nitrogen react with 12 grams of hydrogen to form ammonia. As you remember from the previous lessons, there are many types of stoichiometric problems. Some of them are mass-mass relationship, volume-volume relationship, or mass-volume relationship. But this type of stoichiometry problem is known as limiting reactant problem. You can usually identify a limiting reactant problem by the fact that you are given the amount of two reactants and asked to find the amount of the product. So this problem is the limiting reactant problem because you are given the amount of the two reactants and you are asked to find the amount of the product formed. In this problem, you are asked to identify the limiting reactant in A, the amount of product formed in B, and the amount of the excess reactant remain unreacted in C. As you remember, again, from the previous lesson, to solve all stoichiometric problems, we have to follow the following steps. So we do for this limiting reactant problem. In the first step, we write the balanced chemical equation. For this problem, the balanced chemical equation is 1 molecule of nitrogen react with 3 molecules of hydrogen to form 2 molecules of ammonia. In the second step, we write the amount of reactants and products that's obtained from the balanced chemical equation below the corresponding formulas. So we write 28 grams below nitrogen, 6 grams below hydrogen, and 34 grams below ammonia. In the third step, we write the given mass of the reactants above the corresponding formulas and write X above the formula of the product. So we write 42 grams above nitrogen because the given mass of nitrogen in this problem is 42 grams. And we write 12 grams above hydrogen and write X above ammonia. The fourth step is very important step when we perform the limiting reactant problem, because in this step we can identify which reactant is the limiting reactant and which one is the excess reactant. Therefore, to identify the limiting reactant or the excess reactant, we determine the mass ratio of each reactant and compare the result. As you observe from this step, the ratio of nitrogen is 42 grams divided by 28 grams, which is equals to 1.5. And the ratio of hydrogen is 12 gram over 6 gram, which is equals to 2. Then nitrogen is the limited reactant and hydrogen is the excess reactant, because the ratio of nitrogen is less than the ratio of hydrogen. The fifth step is the final step in most stoichiometric problems. In this step, we calculate the amount of product formed by using the limiting reactant. First, set up the proportions of the limiting reactant and the product. The proportion of the limiting reactant is 42 gram over 28 gram, and this value equals to the proportion of the product, which is x over 34 gram, and solve for x. Finally, we determine the amount of the product formed, that is 51 grams of ammonia. Let me back you to the question itself. We already find the answers of A and B. The answer of A is nitrogen. Nitrogen is the limiting reactant. And also, we identify hydrogen is the excess reactant. And the answer of B is the amount of product produced is 51 grams of ammonia. But we are not solved for C. Let us rewrite the balanced chemical equation and set the amounts of two reactants and the product obtained from the balanced chemical equation below the corresponding formula. That is 28 grams for nitrogen, 6 grams for hydrogen, and 34 grams for ammonia. To calculate the exact amount of hydrogen consumed in this reaction, write Y above hydrogen and write 42 and 51 above nitrogen and ammonia respectively. After this, solve for Y by using one of the proportions. How many grams of hydrogen used up in this reaction? Yes, 9 grams. Now you can determine the amount of hydrogen left over at the end of the reaction by subtracting 9 grams from the given amount of 12 grams. Therefore, the amount of hydrogen left unreacted in this reaction is 3 grams of hydrogen. This is the second example. How much water is produced if 3 grams of hydrogen reacts with 16 grams of oxygen? Just like the first example, we will follow the 5 steps to solve this problem. The first step is write the balanced chemical equation. So, in the first step, we write the balanced chemical equation of this problem. 2 molecules of hydrogen react with 1 molecule of oxygen to produce 2 molecules of water. In the second step, we write the amount of reactants and products below the corresponding formulas, which obtained from the balanced chemical equation. 4 grams, we write 4 grams below hydrogen, 32 grams below oxygen, and 36 grams below water. In the third step, we write the given masses of the reactants and X above the formula of the product. So we write 3 gram above the symbol of or the formula of hydrogen molecule, and 16 gram above the formula of oxygen molecule, and X above the formula of the water molecule. Like in the previous example, in the fourth step, we will determine the ratio of the two reactants to identify which reactant is the limited reactant and which one is the excess reactant. The ratio of hydrogen is 3 gram over 4 gram equals to 0.75, and the ratio of oxygen is 16 gram over 32 gram equals to 0.5. Therefore, oxygen is the limiting reactant and hydrogen is the excess reactant, because the ratio of oxygen is less than the ratio of hydrogen. In the fifth step, we will calculate the amount of the product formed by set up the proportions of the limiting reactant and the product. So, the amount of product produced in this reaction is 18 grams of water. Students, this is the end of today's lesson. In this lesson, we discussed about the meaning of limiting and excess reactants and how to perform stoichiometric calculations of limiting reactant problems. Can you tell me the meaning of limiting reactant and excess reactant? Excellent. And finally, I will give you 12 minutes to do the following exercise, or this exercise. Pause the video for the next 12 minutes and you can check your answers at the end of the video. See you in the next lesson.